Hi guys, welcome to video number 5 on volcanic activity. This time we're focusing on paroxysmal activity or explosive. So because I'm talking about explosive activity, I'm really talking about felsic or intermediate volcanoes. All right, so we're going to go through a number of them and we won't be taking too long to go through them. I think when you look at the PowerPoint, you'll be able to have a bit more of an indication of, I guess, what I'm talking about. So I'm going to go back and we'll talk about ash, which I think is about slide number, oh God, maybe page 43 perhaps. It's just after volcanic bombs. So we're going to start off with ashfall. Okay, what is ashfall? Ashfall is essentially tiny pieces of pulverized rock or it's tiny particles of obsidian or glass. Glassy particles. These particles are very angular, which means they are very destructive and they can break down engines like aircraft engines. If they fly through them. Like I said to you before, one of the ways that ash is the biggest killer is causing roof collapse. The ash builds up on top of the houses, and you have to remember that ash is basically crushed rock. If you're getting 1 to even 2 meters of ash building up on top of a roof, that's 2 meters of solid rock that sits above there. In 1991, the best example of this is in the Philippines. And I'd like you to look at it. It's a mountain called Mount Pinatubo. It's a stratovolcano. Where 722 people died. 200,000 homeless. Most of the people that died, only 350 died during the eruption. And they all died through roof collapse. Mount Pinatubo is right next to Mount Pinatubo is a large Air Force base, and the United States government, who are in charge of that Air Force base, basically told everyone to go to their homes and to stay out of the way. When they did that, they did exactly what they were told, but ash was building up on the roof, and finally most of those houses simply collapsed. It's also one of the reasons why so many people were homeless. The houses were simply destroyed just under the weight of that ash sitting on top of the roof. Something else that happened in Mount Pinatubo is another type of paroxysmal activity. And that is something called a lahar. So, what is a lahar? A lahar is a violent mud flow or debris. I have to say debris because it's not just mud. And it flows down the side of the volcano. So I'll draw a little picture of a volcano. Here's a nice volcano. And if I was to draw this, you'd think it looks like Mount Fuji. But all of this on top of the volcano is snow. Sometimes it's ice. During a volcanic eruption, this whole area is heated up. And sometimes there are small eruptions called phreatic eruptions. And a phreatic eruption is like a steam eruption. It's phreatic. This melts the snow. Now, at the same time as a phreatic eruption or as a major eruption, let's say we have an eruption happen and we've got some ash falling out of the volcano. That mixes, the ash mixes with the melt water. And that forms this mud, this hot, thick mud or slurry which flows down the side of the volcano. It flows down very, very fast. Now I'm going to try and show you a little bit of footage here, and I hope the phone will work. I don't know if you can see that. Can you see that maybe? Anyway, this is on YouTube, and I'll just show you this image of some lahars in Japan. So this is in the north of Japan, and we've got large amounts of debris all flowing violently down the side of the volcano. So if you look at this, I'll put a link on there for you, and you can watch it in action. Very, very violent stuff. If you can imagine this lahar, it's not cold, it's hot. You're talking about temperatures of about 300, possibly 400 degrees Celsius. Very, very, very hot ash and very, very hot water, and it flows down the side of that volcano. Actually, it's a bit of an exaggeration. It's probably more closer to the near boiling mark. So these lahars, again, when this material stops flowing, it sort of behaves in a similar way to some lavas in that it becomes fairly solid. Right, let me stop showing you that. So that's called lahars in Japan, if you want to look at the YouTube video of that. So let's look at the cause, and we'll write this down. So a lahar is a violent mud and debris flow. Cause. Cause is a volcanic eruption of steam or ash. It melts the ice or snow. So it melts the ice or snow on high altitude volcanoes, forming a slurry of ash, mud, volcanic bombs, large debris, It'll pick up trees, buildings, cars, and flows it down the side of the mountain. This lahar then flows so the most famous lahar is actually in Colombia, and a volcano called Nevado del Ruiz. Nevado del Ruiz. And there is a town approximately 50 kilometres called Armero. And I just want to get just trying to find out the distance from the volcano. Armero is about 50 kilometres from the volcano. I just want to make sure I get that data right for you. Now, this lahar flowed down the slopes of the volcano. It was travelling at about 50 kilometres an hour, and it flowed right into this town. When it flowed into the town, it was actually fairly early in the morning. People weren't ready for it, and it killed 22,000 people. Now, the trouble with this particular tragedy itself, and I'll continue here, (1985), Armero, 22,000 dead. The trouble with I guess the tragedy with Armero is that the United States Geological Survey had actually gone into the area and told the government about this volcano. They had gone in and said, look, you've got a lot of ice, you've got a lot of snow up the top there, and we've also seen a large amount of increased volcanic activity. You need to move people away from this area. And the government then produced a map, but nobody could understand it and nobody could read it. Because nobody could read it or comprehend it, they couldn't act. USGS had visited prior to the eruption. They warned the government of impending danger. Unfortunately, the people of Colombia could not, if you say translate or comprehend or understand the map or what the volcanologists have said, and because they couldn't understand it, they couldn't act. Could not read or understand the warnings. So they did nothing. I guess what's important here is that it's very important that the right language is used for the type of audience that you have. So for example, the United States Geological Survey and the government of Colombia, well, what they could have done and what they should have done is they should have actually worked together on creating a map or something that people could understand and therefore act upon. So this was something that could have been stopped, but unfortunately it wasn't, and all those people died. I really suggest you look up and you look at this as an example. Armero is a great example of a lahar and how those people died. Essentially, when this lahar stopped flowing, it came and set like concrete. And if you look at the YouTube footage of it, it's pretty devastating. It's actually pretty shocking stuff. But I do recommend that you look at it. They have made new maps of the area, and I'll just show you one on the computer now. And you can see here that we've got Navallo del Ruiz is over here, but then we've got 15 kilometers, so about 45 kilometers further on, down the Languilas River is Armero, and it simply just flows all the way down that valley there. There were other areas, but they didn't actually get, they weren't built on the river, on the floodplains, if you will, and so they actually didn't get any of that damage. If you look at this new map, you can see they've got different colours for different hazards. So they've got a pyroclastic flow hazard in yellow, they've got a high pyroclastic flow hazard in orange, and you can see the lahar hazard is in red. So that's lahars. The last one that we want to look at today is pyroclastic flows. All right, pyroclastic flows. Exciting stuff, these guys. They are the most violent form of volcanic activity, and they, I guess they're the quickest. They happen the fastest. Ash will build up over a long time, and a lahar will occur, and it might actually cause the deaths a lot further on down the line. Lava flows are fairly slow, and gas eruptions, well, I guess they're silent but deadly. But pyroclastic flows, well, those guys, once the eruption or the event happens, the devastation happens almost immediately. Now, there's two types of pyroclastic flows. Well, actually, maybe I should tell you what pyroclastic flow is beforehand. A pyroclastic flow is, I guess you could say, an avalanche or a landslide, but instead of rock or ice, it is hot ash and tephra, hot ash and volcanic material. So it's a fast-moving flow or current of gas, and that's hot gas, and volcanic, let's call it matter. They can be up to 1,000 degrees Celsius in terms of temperature. They can travel up to 700 kilometers an hour. That speed depends on the angle that they flow at. The lower the angle, the slower they will flow. I'll show you an example of a rock that has formed in this sort of way. And if you look at this, you can see we've got large sort of, I guess you could say it's porphyritic in its formation, but it's made of very, very small matrix of ash and volcanic material. But then around it, we've also got some large crystals of or large other pieces of rock, and that rock would be like a rhyolite or something like that, or maybe an andesite. This would have been formed in that sort of pyroclastic flow. There are two types. They're caused by, number one, lava dome or spire collapse. Best examples of this are at Montserrat. I think it's double T, no it's not. And that's in the Caribbean. Mount Unzen in Japan. Mount Vesuvius in Italy. Another one is called Mount Pelée. And that's also in the Caribbean. It's also been called a Plinian eruption. And that comes from Pliny, who was the guy he was a Roman writer, and he was sitting across the Bay of Naples in his house, and he was watching Mount Vesuvius erupt, and he described the whole thing. So they've named it after him. So what happens with a lava dome collapse? Well, if we think about a lava dome, it builds up over time. As it gets bigger and bigger, some parts become fragile, and they simply fall off and flow down the mountain. You've also got the build-up of spires. You might remember when I was talking about felsic magmas, these spires simply fall and they create a pyroclastic flow. So build up. So build-up of lava dome, subsequent collapse, and then flow. There are three ways to die in a pyroclastic flow. I guess you would die by suffocating. Two, I think it cauterizes your lungs so you can't breathe. Actually, I guess that's the type of suffocation again, isn't it? And then you get hit on the head. So there's large, inside a pyroclastic flow, and I'll draw another picture of one in a second, there's large boulders. So you get crushed or get cooked. So if you turn to your PowerPoint, and we'll go down to, go past all the description. Here we go, pyroclastic flow and pyroclastic surge. Now, pyroclastic flow is our lava dome collapse. And if you look at the picture of a pyroclastic flow, it's got like a slope, and then we have large particles on the bottom. These are large boulders. These could be a couple of meters in diameter or even smaller. Then we have a sort of build-up of other material, so like even slightly smaller pieces of ash, and then we have a much larger dome, if you will, of a very fine ash material. So you notice I've labelled it ash, lapilli, and bombs. So it's layered. A pyroclastic flow is layered. And this will simply flow down. And what's forcing this? It's gravity. All right. So that's a pyroclastic flow. And I've put some pictures of them on the PowerPoint. Bit of more information there about that. It's also thought that a pyroclastic flow killed the people on White Island this year. Horrible way to die, but very quick. They wouldn't have suffered, those poor people. And you'll notice there's a little like a concrete tunnel. I'll talk about that in our next lesson because we're going to talk about mitigation for mitigation of volcanic activity. Before I finish on lava pyroclastic flows, I will say the other type is a pyroclastic surge. This is what happened at Mount St. Helens. So a surge is different from a flow. It's not driven by gravity, but it's been pushed by an eruption. Explosive activity driven by an eruption. If you think about Mount St. Helens, there it is. And there's our cutaway. Here's our magma chamber. And here's our material being pushed out. That's the surge. 1980. All right, that's it for today. Let's see if we can think of a question that you guys could do for homework. Question time. I've put myself on the spot now because I can't actually think of a question. All right. Oh gosh, that's terrible that I've done that to myself. So, question one. I can't actually think of a question right now. Let's go with describe the type of volcanic activity seen at Mount Kilauea. Identify how it is different from, let's go with Mount Vesuvius in terms of structure and eruption features. Question one. Question two. Question two. How is a lahar different from a regular mud slide or flow? 3. Ali, can you think of a question? Tom, we've got a question. Ooh, okay then. Let's go with what possible information can be gathered in order to predict that or predict an eruption. that question's good because that's what we're looking at in our next lesson, making predictions and mitigating against volcanic activity. There was one question, there's one last little thing that I'll talk to you about. And there was a question I asked you guys a while ago when everyone was in class, and we talked about Miss Power in Hawaii. And I asked you a question. What was the question? Do you remember it? I remember the question.
Is that coral in Hawaii?
Why coral beaches and not sand? That was the question. It was asked in a roundabout way, which is the way you have to get used to. Do you know?
Is it because the islands are surrounded by coral?
Okay, so number one, the island is surrounded by coral. Yep, and there's also a lot of coral as well in the seamounts nearby. So island is surrounded by coral. It's also got a tropical temperature, so coral can form. Why no sand? That's the big question though. What rock does sand appear in? Or what rock, what's sand made out of? Sand's, do you know, Tom? Sand is made out of a material called SiO2. And for those of you playing at home, that is the mineral. Yep, you got it. It's quartz. So what rock do we get a lot of quartz in? Well, I'll tell you what rock we don't get quartz in. We don't get quartz in basalt. And if we're thinking about Hawaii and the islands are made out of basaltic magma, then you're not going to have that material to make the beaches. The only thing you're going to make beaches out of is whatever material you've got around. So that's why some places in some countries like Iceland or in Greece, there's a couple of islands in Greece where the beaches have black sand. And the black sand is pyroxene, the mineral, or biotite mica. It's very cool. Those beaches get really hot though. You have to you think our beaches get hot, the black sand just holds that heat in and just melts your feet. But quartz is something that's in granite. So next time you guys are down at Scarborough, when COVID's all over, you can go to Scarborough and you can thank the granite that's up in the hills for the beaches that are there, because it's the sand that has come out of that granite that's actually formed those beaches. When granite breaks down, feldspar breaks up. That turns into clay. Biotite is in, so there's not enough of it, so that washes away, leaving just the quartz. And if you want evidence, just dig a hole in your backyard and see how much quartz you've got there. And that's because everything that was above it was kilometres and kilometres of granite. Everything else is washed away and we're left with nothing but that sand left. So Hawaii doesn't have any sandy beaches because there is simply no rock there with quartz in it. Cool. If you can think of a question like that you could write yourself, I think that would be a really good idea. Also, there's the bell. But there's one little tip I've got for you. Perhaps some of you might be able to, obviously it's really important that you guys are answering questions. So I'm wondering if you guys would like to write yourselves little tests that you could each do. When you write a question, you really get an understanding of what the subject is about, and you need a certain amount of knowledge when you write a question. If you're away, because we have lots of time in this period, I'm really hoping that you'll use this time to maybe write yourselves little tests and exams. Put them on your group chat and share them. Don't have to give them to me, you don't have to show me at all, but just talk amongst yourselves about what's there. Okay, next video is up on Monday, and I'll try and put about 2 or 3 up I'll try and do 5 or 6 videos next week when I've got no classes to take. All right, message me if you need, email me if you need anything. See you guys.